bias-variance trade-off. Now, a bias-variance trade-off is an idea which helps us relate with something which we call as the idea of overfitting and or model overfit, as we call it. Now, this is also something which we study as a part of model specs or model specification. Now, bias-variance trade-off popularly, it's a very popular concept which we study as a part of machine learning. So I would say any lecture you study on machine learning, the very first or probably the first couple of sessions will always talk of bias-variance trade-off, because this talks about how exactly we choose our explanatory variables in our model. Now, if the model has way too many independent variables or way too many explanatory variables, the problem is we are risking the model of being overfit. So what do you mean by overfit? You have just explained it here in the bracket. So when you say a model has been overfit, then that means the model understands the in-sample data really well. But if it's presented with an out-of-sample data, it may so happen that the model may fail miserably. So for example, let's say that we have a large number of parameters, and let's say my current model accuracy, let's say my R squared, or maybe just take accuracy, let's ignore R squared. Let's say model accuracy is like 90%. I'm delighted. I have a very high accuracy. But the problem may be I might be overfitting my model because I have a current data set which my model is exposed to, and it's giving a very high accuracy because I have so many number of explanatory variables that I have made my model very, very flexible. So that way, when I say flexible, it's flexible for flexibility to understand what is there in the current data set, not otherwise. Now, let's say tomorrow we have an entirely new data set coming in and we just use that model directly. Now, the problem is let's say there are let's say I choose n equal to 7. Now, these are my number of explanatory variables or independent parameters. Now, I had initially fit my model for these 7 parameters and I had a very high accuracy. I was very happy about it. Now, let's say we have a new set of data coming in. Now, the problem is it becomes a very difficult task if we have to tune so many parameters. Because whenever we have to tune these many parameters, the thing is it is going to make our model unstable, because then the model needs to find the best fit values for so many parameters or so many coefficients, isn't it? And it is because of this that the model's accuracy can drop. So that way this 90% can drop drastically also if it's presented with a new data set. So that's why as a part of model specification, this appropriate number and appropriate choosing of explanatory variables is very, very important. Now we know the idea of overfitting the model, right? So overfit models have a high bias error due to the inclusion of way too many independent variables. Whereas smaller models, if we consider, they can be exposed to high variance errors. So here I've shown what we call as a bullseye plot. And this bullseye plot helps us relate with the idea of bias and variance in a very nice manner. So along the top row, we have the variance. So we have low and high variance. And along the first column, we have the low and high bias. So let's try to relate them. Now, from this bullseye chart, it becomes evident that now this is the most ideal one, isn't it? Low variance and low bias, because all of my points are right there in between. So that way, the accuracy of this is very, very good. And that way, this is something which every data scientist would dream for, isn't it? So a low variance and low bias. Next, we have a low variance, high variance and low bias. Still, I would say it's not that bad, because yes, I mean, we do have these points which are distributed along the bullseye. It's not exactly centered on the bullseye, but still there's more or less in the vicinity. So still a not bad choice. However, whenever we have a high bias, low variance, and high bias and high variance, then the thing is, if you observe, whenever there's a high bias, these points are grouped together, and that way they are away from the bullseye. And whenever it is high variance and high bias, not only are these points away from the bullseye, but also they are widely dispersed with respect to each other as well. So that way, this is something which we ideally don't want, isn't it? So we would want to stay away from these kind of things. So that's exactly what has been mentioned here as well. So again, a very, very important idea, because once we understand the idea of bias and variance, it also helps us figure out how complex our model should get. Because yes, we might feel that if the model is very complex, it might give us a very high accuracy. It may for a certain data set, but that's not guaranteed, because if the model gets very complex, i.e., if we have too many independent variables, then the thing is, if the model is presented with a separate set of data, then tuning those many number of independent parameters can become very difficult. So I would say generally from modeling exercise, you should try and minimize the number of independent parameters which go in. That is, try to stick to your parsimonious model idea. And that way it can help us tackle the problem of bias and variance. And we are able to then choose the right set of parameters which can aid in a higher model accuracy as well.